So I didn't realize until after lunch, they actually have a whole instruction packet for me up here. So I have not been following it, but we have check-in. For each of our sessions, so I apologize about that. But thank you, Joe, for that presentation. I think it ties in well with a lot of what we heard yesterday from DOTs and some of the training requirements. So for our next session, we will be bringing up Utsab Pokorel. I asked him how to pronounce it, so I hope I got it close. And his presentation is Unveiling the Skies, Revolutionizing Bridge Inspections in the USA Through Drone Technology. Utsab is a senior engineer in the structural evaluation at New Jersey Department of Transportation, where they do bridge and culvert, sign structures, high-mast light pole inspections to meet with federal compliance. He initiated the concept of inspecting the bridges using the drones to increase safety and efficiency, saving time and money. Currently, he is leading this project and recently organized a conference with Skydio on drones for New Jersey DOT bridge inspection proof of concept. He is also the course introducer and a technical panelist for AASHTO Technical Training Solutions, formerly TC3, on application of unmanned aerial systems for in-service bridge inspection to widen the knowledge sharing process and provide technical guidance for bridge inspectors on drones. This course is expected to come soon through AASHTO Technical Training Solutions. So let's welcome Utsab.
Good afternoon, everyone. I'm Utsab Pokorel. This is my first year at this conference, and great to meet you all. It's really is a great conference. Thank you, George and team, for making it a great event, and big thank you for JD for inviting me here. As mentioned, I believe in Monday. You need to get surrounded with smart people, so I'm here with you all. So this presentation explores transformative potential of drone technology in revolutionizing the bridge inspection process across USA. So bridge inspection. So bridge inspection plays a pivotal role in ensuring safety, longevity, and operational efficiency of critical transportation infrastructure in the United States. Bridge inspection are a critical part of preserving our nation's bridges to identify current conditions, needed improvements, and provide recommendations. Any bridge recommendations will be provided by the inspector so that bridge can be repaired. The duration timeline of the repair recommendation will be categorized based on the criticality and extent of the defects. As per National Bridge Inspection Standard, all bridges in USA are routinely inspected every 24 months at least, and NBIS regulations apply to all the bridges greater than or equals to 20 feet. So upon notification with FSWA, some conditions as set forth by NBIS, such as deck, superstructure, substructure, culvert conditions greater than or equals to 6 and more, and inspection intervals greater than 24 months, but less than 48 months are allowed in some special conditions. There may be interim inspection that may be required, and that makes inspection frequency as 12 months, 6 months, and even monthly inspection as well. So there are over 617,000 bridges in entire USA. Tracking, collecting, and maintaining large number of inventory of bridges with proper record keeping of all defects is really challenging for all the different structural members that we have in the bridge. So there are more types of inspections, such as underwater fracture critical inspections and more. So all the inspection activities are made lively by significant funds invested in bridge inspection activities. So new specifications for National Bridge Inventory is recently published, and it's SNBI, and it's gonna go in effect soon. So thank you FSWA for recognizing unmanned aerial vehicles as inspection equipment in SNBI. I see that. So now it's time for drone for asset inspection. So drone, as you know, it's unmanned aerial vehicles used to capture different types of imagery, such as images, videos, thermal image, and now 3D data as well. It is used to in multiple sectors, such as inspection, construction, agriculture, rescue operations, surveying, delivery, wildfire tracking, and much more. So for bridges, culvert, high mast light poles, science structures, drones can provide more visual coverage of assets, for there are many components which are difficult to reach out to inspector, and drones can capture the required data in no time. In fact, more data will be captured. Drones can maneuver in almost all locations with minimal case of missing defects, since we can still go through the footage back in office. With drones, I feel it's a new era of bridge inspection. So I feel drones is really bringing bridges back to our office desks to make informed decision with all those data, 3D capture, and now with head-mounted displays, AI, and defect quantification technology. It's really a different ballgame. So let me show you a typical setup that we do for traditional bridge inspection. So this is footage for traffic control in action in Interstate Highway I-295 at New Jersey. We are using 3 heavy crash truck attenuators for bridge inspection to protect our bridge inspectors. So let me play this video. Yeah. So there are vehicles coming from ramp lane to merge in Interstate Highway. So there will be issues with merging driver, for there are stationary crash truck parked right there, and they are left with very soft merge with increase in blind spot, and it's a 65-mile post limit, and traffic density was increased as well. Sorry, the video got forwarded. So on the other end, here's our bridge inspectors performing bridge inspection at I-295. We are doing deck inspection here. We are separated by high-speed incoming traffic with 28-inch cones and backed by crash truck attenuators. Bridge inspection workers are vulnerable to be struck with high-speed moving vehicles, and they are just separated with incoming traffic with the cones. So here's a sample drone footage performing cursory inspection. I think it was greater than or equal to 7. So as per NBIS, which means there are typically no defects. Also, bridge inspectors can hardly see what's going on the left lane. They can just see the lane that's closed and beside that. So, and we have to close other side as well. Though it didn't have much defects, but that's like a typical setup for the procedure, and that's how we do it. And this is another video for Washington Crossing Bridge. This bridge is located at border of Pennsylvania and New Jersey, built in symbolizing where our first president, George Washington, crossed the Delaware River to New Jersey in 1776. Using drones, we can reach out to top chords of this truss bridge easily in no time and reach to physically challenging areas easily to capture full bridge. Just to see the rust in top chords right here, either you may need to go with labor-intensive risky ropes or use road closer with heavy equipments, and which will impact roadway traffic, for it is very narrow lanes, narrow 2 lanes here. And now drones with accuracy, I feel it's time to revolutionize our bridge inspection procedures. So instead of affecting traffic, putting inspector at risk, use of costly heavy equipment, we could have inspected this kind of bridges with drones from safe ground, minimum closures for reducing public impact, simplification of inspection with time savings, reducing use of costly heavy equipment, and enhancing the data quality that we collect. So in-house drone capabilities can allow for rapid bridge emergency response as well, whereas right now we are bogged down with waiting for deployment of specialized vehicles where like there may be cases with girder hits. There are lots of cases with girder hits by trucks with low underclearance. So I'm not saying that drones can replace all the human inspectors, but there are some bridges that needs hands-on inspection, such as fracture critical bridges, and bridges that need special testing, such as hammer-on, non-destructive testing for defects, but drone can identify the places which needs detailed review and then plan for hands-on inspection wherever it's essential. So let me summarize the advantages again over here. So drones can enhance safety by reducing exposure of human inspectors and public to vulnerable environment. We can reduce public traffic impact by reducing number of lane shoulder closures, like I showed you in video before, and it'll be safe for inspector since they will be at safe ground. So let me show you one picture. This is picture of Rhode Island. There are two inspectors inspecting the bridge. Some may be familiar with this picture as well. So the UB60 got tilted while they were inspecting the bridge. So another UB60 has to brought in to be, so that the inspector has to be rescued. And getting UB60 is very tough with scheduling because we have so limited UB60 right here. So if we could use drones and identify the critical areas, I think we could minimize the use of UB60. And these are some risks associated with bridge inspection. These are the published articles. So first incident is an inspector that fell 140 feet to death, striking to railroad underneath during inspection. And another case, it was drowning in New Jersey at Passaic River. There's another incident of death reported where individual contracted by PennDOT was controlling bucket truck himself, but got too close of the beam and got crushed himself while operating a bucket truck. And we recently had one incident in-house as well. So we had to inspect a bridge with UB60 over a river, so that we need to put boat underneath for safety as well. One of our colleagues at NGDOT mistakenly hit reverse instead of forward at the boat ramp with large motorboat in it. So one of our vehicle drowned with boat and inspector in it as well. So thankfully our inspector was safe because there were some kayakers doing kayaking over there, and they rescued her. She just delivered a kid and was going through recovering process. It would be very bad if something would have happened to her. Now she left our unit. Now she's in pavement design. The vehicle and the boat couldn't be even found until like 3 days. It went so deep downstream. So you all may have similar incidents in inspection as well. So I believe we should put machines instead of humans at risk, especially for the bridges with UB60 that takes lots of our resources. So going back to my advantages slides. So number 2, it is with drones for emergencies, they can be deployed as our first responder to the site, since we are often our time goes by scheduling for heavy equipment, doing road closures. And for simplification and time savings, traditionally we use snooper trucks, bucket trucks, ropes, boats, coordination with third party, and scheduling them is tough. Depending upon bridge type, drone requires fewer resources and enable swift data collection and analysis. Fly ready within a minute or two. Even with ladder, it takes like 10 minutes just to take it out, put back in, and we have to erect it, go up, and stuff like that. Also, drones can reach out to most part of the bridge. With ladders, we just put like 1 or 2 places, but with drones, we can just fly over wherever we need it, like all the bearings, all the pier caps, and places like that. So drones can reach out to challenging portions of bridge easily, such as truss bridge, as I showed you earlier. The best part is we can get a top general overview of the bridge, like shown in the picture at the right. So we can also see traffic pattern, roadway design, and even waterway channel movement for the scout critical bridges as well. So cost of field inspection can be significantly reduced by using drones due to time savings with inspections and reducing the use of costly heavy equipment. I have to go through another slide again showing the cost. So drones that can be used for bridge inspection typically ranges from like 1,000 to 25,000. This is a rental cost that we use in New Jersey for daily basis. So right now, the prevalent highway equipment rental costs with crew numbers are shown here. We are paying 7,750 to rent UV60 for a single day. Utilizing drones, we can minimize the use of UV60, for it involves risks, multiple lane closures, public impact, reduced cost, and time of inspections. I have recorded data that shows that just to go down and UV60 to come up, it takes more than 20 minutes without doing any inspections. So as per Minnesota DOT, I think it published a report in 2018 improving the quality of breeze inspections using unmanned aircraft system done by Barrett Loveless. So this is some cost-based research finding by Minnesota DOT. Research on wide range of bridges, including complex fracture-critical bridges, bridges over waterway, roadway, railroad swamps, and regular NBIS bridges, and came to conclusions with savings ranges from -72 to +79, with overall cost saving of 40%. So -72 is sometimes we just it's better to just go in person without using drones, and wherever heavy equipment is not necessary, and due to operator and post-processing costs, +79 for the for not using snooper truck, bucket truck, and lane closures. So I think I have sorry to go back and forth. I think I missed some. Yes, so I'm in bullet number 6. So with new technology in place, we can literally bring up bridges to office, meaning with 3D data, we can access all the bridges sitting in office. Now we can incorporate our field notes in the model itself, just imagining how easier it'll be another person that's going through our bridge inspection report to see our inspection findings. The data collected by drones can be processed using computer vision algorithms, artificial intelligence, machine learning techniques, enabling automatic detection and analysis now as well. It can improve the accuracy and reliability of inspections, leading to informed decision making regarding maintenance and budget allocation as well. The combination of aerial imagery and advanced analytics really eases the inspection process, reduces human error, and provides valuable insights for maintenance and rehabilitation strategies as well. Drones can facilitate the creation of comprehensive 3D models, point clouds, orthomosaic maps, which can aid engineers, policymakers, and stakeholders in visualizing the bridge condition and prioritizing necessary bridge repairs for operations as well. Nowadays, we have autonomous drones and data processing companies and AI in place, which can really give precision. So we can create twin models as well, so that similar bridge can be reconstructed again. We can preserve those data for critical infrastructure, such as historical bridges. So although bridge repairs cannot be done without reaching out to defects, I think inspection may be performed with drones wherever hands-on inspection is not required. So I think I've gone through all these slides. So this is 3D data capture that we did for 3 bridges. We recently did it. It was submitted like one month ago. We allocated some hours for inspecting using drones. We gave 5 NBIS bridges to AI engineers, our in-house bridge inspection consultant. So these are small bridges. We did this to get an idea and showcase work. What can be done with 3D model. Since I cannot scroll myself, I just recorded screen capture here, so it may not be that good efficiency. So, and this is another bridge. It's structure 1000078. It's Hunterdon County. This is a county bridge as well. NBIS bridges, small one. So we did some 3D data delivery for this one and this one as well. It's arc bridge. So these were recently done by one of our consultant AI engineers. And seeing these details, like I think it's time to uh, deliver data in like 3D functionality rather than our breeze inspection reports with photos and words. So there, every aspect has some limitations somewhere. So these are some of the limitations that I've been facing. So most of my services, people are kind of reluctant to use drones. Most of my seniors, for years we have been always inspecting from ground for 52 years. After publication of NBIS at 1971, it could really be easier if FSWA could provide concrete guidance to state DOT, such as manual NBI training course for breeze inspectors. I feel we are missing the regulatory frameworks for integrating drones in state level. But recently, FSWA James announced that there are some NHI courses coming, so I'm really excited for that course to come up, and so that we can start something in state level as well. So I'm also a course introducer for one of the ISTO courses, application of US for in-service breeze inspection, and I'm working as technical panelist. This course is under development, and like I said, federal level course will be more more to emphasize real use case scenario for breeze inspections. So when I take out drones for breeze inspection, my seniors still say that, what are you doing? I don't want it here, get it out of here, something like that. And I try to explain them calmly and saying, so look, this allows me to stay here, capture data of that bearing without use of any big equipment, without putting ladders in, without putting bucket trucks in, so I can check out all the girders in no time. So, and I have to say that same thing time and again and again and again. And the funny thing is, I won't be tired of explaining, because I feel like this technology can make us more efficient, safer, and productive. And again, I'm not saying drone replaces human inspector, but provide great foundation for breeze inspection procedure to identify critical location of the defects. So there are some operation limits. All federal regulations are in effect to ensure proper use of drones. First and foremost, commercial drone operators should be commercially licensed. FAA Part 107, drones needs to be registered. There are some operation limits, such as drones cannot be flown near airspace within, I believe it's 2 miles, and drones always needs to be visual in visual line of sight. Some state DOTs, such as North Carolina, have been awarded by FAA a waiver to operate drones beyond visual line of sight. So I believe some more state agency needs to work on that as well. So due to confined space and locations, there may be chance of poor GPS signals. So we need to, the solution would be, we need to use drones without GPS, and we have tons of those kind of drones right now. So there may be battery capacity limits, and there are, depending upon drones, we have like 15 to 45 minutes per battery. I feel like that needs to be increased a little bit. Bringing drones down and putting back up, it's more time consuming. I believe there are some research going on to increase flight capacity, flight timing for the drones. So we just need to make sure that we have plenty of spare batteries. And drones, like any other vehicles, are very susceptible to collision. Nowadays, drones have great feature that is obstacle avoidance. So I feel like we are overcoming that challenge by using drones with obstacle avoidance. So with drones, we have lots of data. So post-processing may be required, and proper space allocation needs to be done. So we may need to allocate extra cloud or hard drive to store data, but they can be cheap compared to heavy equipment and intensive manpower that we use. So clear and sunny weather always gives best footage. Most drones are not waterproof. It cannot be operated in rains. and snow, high winds, and sometimes even in high humidity. Commercial drones can be flown in wind between 10 to 30 miles per hour. Lower the wind, better the result, since drone will be stable. Drones with flashlights is preferred for breeze inspection. For some components, needs additional flights to be attached. So drones can, it's not hands-on. So drones cannot replace fully hands-on inspection, but gives a great opportunity to areas you can see traditionally harder to access places with snoopers, and we can get a good idea on what condition it is, where we need to focus our efforts on. So a well-trained operator can operate drones safely and overcome listed limitations. Using drones could be challenging, as the case with new technology that has eventually simplified our daily work functions, such as computers, mobile devices. Training, we need to provide proper training. Even NJDOT has mandate that even though we have part FA Part 107, we still need to go through our NJDOT competency check, flight operation check, and we have specific procedures to do that. So until we get that lined up, we can't fly commercially for New Jersey. So there are some privacy concerns and public perceptions, and that needs careful consideration to address potential issues and build public trust. So we can explain the critical work that we are doing preserving our national infrastructure. We need to try to keep off limits with private property and not being intrusive. So we need to get like permission right away if we are using private properties. Sorry. So we may use distractions such as flashing lights of our vehicles as well to distract the general people when we are operating drones near a roadway. So it's always a learning curve. So more we do it, more we learn. So I want to reiterate our Assistant Commissioner, Mr. Portoza, comments when I did the proof of concept for NJDOT. Just do it. You won't know until we do it. So it really encouraged my efforts. That's why I'm trying to explore more and work more on this topic. And we are leaning to new operation techniques day by day. And we have right now 2 commercially licensed in-house breeze inspectors, and we have 2 more scheduled by the end of this year. So, and also proper budget and work allocation needs to be provided to the people who are working it. It's kind of lacking in that sense. So I feel I have more points with challenges than advantages, but I feel we can overcome all the challenges and getting bigger picture of what we are getting out of it. If I miss any advantages or challenges, limitations, it will be great to hear from you all. So we are just beginning in this phase of the program. Tons of things to do. Tiny rotor in a huge ship. It will take time, but as a certified breeze inspector and senior engineer at New Jersey Department of Transportation, I feel that use of drones for breeze inspection is inevitable, and it'll come for sure. So as this technology continues to evolve, breeze inspections in USA, will be benefited from increased automations, improved data analytics, and enhanced decision support systems. Integration of drones presents an unprecedented opportunity to transform the way bridges are inspected, ensuring the resilience and longevity of critical transportation infrastructure. I'm Utsa Pokhral again, Senior Engineer, Structure Eval. There's my contact information. If you have any questions, suggestions, I'll be more than happy to get back to you all. Thank you so much. If you have any questions, thank you so much.
So I didn't realize until after lunch, they actually have a whole instruction packet for me up here. So I have not been following it, but we have check-in. For each of our sessions, so I apologize about that. But thank you, Joe, for that presentation. I think it ties in well with a lot of what we heard yesterday from DOTs and some of the training requirements. So for our next session, we will be bringing up Utsab Pokorel. I asked him how to pronounce it, so I hope I got it close. And his presentation is Unveiling.